Alright, let's express this. Okay, I've got about 20 minutes before I gotta get ready, pack up my bags, and run off to school and get on a bus. So here we go. Exponential and logs, exercise 9G and H. I don't think I can do circular functions in time. So circular functions is just sine of x, cos of x, tan of x. You just got to remember the rules. If you understand how to do exponential and logs, it's got to be exactly the same for sine, cos, and tan. You just got to remember the rules for it. Okay? And it's in your textbook, or you can go back to the files I mentioned in the power rule video. Okay, power rule comes first. The power rule video will tell you or show you that I've put up some files for 2015 just to recap for some of the new students on calculus and skills. So you can use the same notes to do the questions, practice again. Okay, revise, revise, revise. All right, here we go. 9GH. Let's go, let's go, let's go. Come on, move, move. All right. Exponential derivatives, what you need to remember is this one rule. Okay, so y equals 2. This is all we know. Remember, that's what I said last year. This is all we know. We only know y equals e to the power of x. If it is that, if it's exactly what you see there, then the derivative is itself. Okay? We don't know if it's e to the power of negative x. We don't know that. If it's e to the power of 2x, we don't know that. If it's e to the power of x squared, we don't know that. All we know is if it's e to the power of x, the derivative is e to the power of x. That's all you need to know. That's the rule. If you have to take notes, that's the one note you take. Now, let's take out the first example, a. Okay, let's say we do a. So it's e to the power of 5x, right? So y equals to e to the power of 5x. That's an issue. I don't know that. I have no idea what that equals to, because all I knew was e to the power of x. So this is where chain rule comes in. So hopefully you watched chain rule before you went to exponentials and log. The order is power rule, chain rule, then exponential and logs. Okay? So if you're on to this without looking at chain rule and power rule, go back. Do chain rule and power rule. Okay? You got to be able to do those two first in order to do these well. So, having said that, so let's assume that your chain rule is perfect. Okay, we are now going to say we're going to replace this value 5x. Why? Because that is your inside function. Remember I said composite functions, right? This is the same thing as splitting it up into two, where you can say, whoops, splitting up into two functions, and you can say that this is split up into two functions. It's e to the power of x, and you have 5x. Okay, so g of x is your 5x, and you're substituting that within. So that's why it's a function within another function. It's a linear function within an exponential function. That's what you're really doing. Okay, so that's why you know you can use a chain rule. So if we're using the chain rule, all right. Chain rule tells me I am going to. Oh, whoa. No. Okay, chain rule tells me I'm going to now replace the 5x with a u, so let's call it u equals to 5x. Why do I do that? Because this now becomes y equals e to the power of u. Now look at that. That looks so similar to this one. The only difference is the letter's different. So that means the derivative should be the same as in theory. So this means dy du has to equal to e to the power of u. Woo! Okay, we're done. So we got that part down. And now we're looking at du dx. So let's have a look at that. So we know the derivative of this is just power rule. Drop down the 1, so that now becomes 5. Oops, just 5, sorry. I got carried away. There we go. Okay, derivative of 5x is just 5. So if we had to answer the question, the answer is simply dy dx must equal to, you multiply these two together, remember chain rule, multiply those two together, it's e to the power of u times 5, which works out to be 5e to the power of 5x. Now I know your textbook gives you a different rule. They do this, they do e to the power of kx, and then they give you a rule, they go dy dx equals to ke kx. And I know that if you had followed that rule, you would have been able to do a in an instant. Yes, true. Problem with that is if you get, for example, this problem, that wouldn't work and you screw up. Okay, that's why I'm trying to teach you the basics. I said chain rule is the bread and butter of your course for chapter 9. Okay, don't deviate from what I'm trying to teach you. I'm trying to give you the most efficient way to understand how to do your problems. Okay, so I know, yes, there is this rule, but that only is temporary. That only helps you to do these in year 11 mathematics. Yes, you would have been fine up until you get to these problems. Okay, so when you get faster at these, what you can do is you can start saying, all right, well, I'm going to look at all this and I'm going to say, all right, see that? I can start doing that in my head because I now know which one is the inside function and I know which one's the outside function. So the inside function is clearly negative 3x. So in my head, I'll do derivative of negative 3x. Well, that's negative 3. So I'm like, okay. Remember, you're going to find the derivative inside times the derivative of the outside. So I'm going to find the derivative of the inside, which is negative 3, times, now derivative of the outside, I pretend that this didn't exist. I pretend it was just 7eu. Now, this is just 7 times e to the power of u. But we know the derivative of e to u is just eu. So technically, the derivative of dy du is equal to 7eu. So this is 7e to the power of u. But u was negative 3x. That's, I've sort of removed all that, but it's negative 3x. So I know the answer is this. So times it together, that's negative 21e negative 3x. Now if that was too fast, I'm going to do it slower. Okay? So what I'm doing is, this is what I'm saying. If y equals to 7e negative 3x, right? What I'm trying to say is you start picking up patterns and you can say, all right, let's call that u. So I'm going to take the long way so you can see what I'm doing. I'm going to call that u. So u equals negative 3x, right? Why do I do that? Because this changes the equation now to become y equals 7e to the power of u, right? Now, du dx is just the derivative of the inside, which is why I said before derivative of the inside is negative 3. Now, this one, I know a lot of students get confused because you're so used to finding derivative of eu and you don't know what to do with that 7 if it's at the front. Well, if I gave you x squared, think of it this way, okay? If I gave you x squared and I asked you find the derivative, you would have said dy dx is equal to, bring the 2 down, and it's x to the power of 1, right? So even if I asked you y equals to 7x squared, and I asked you what's the answer, you would have said y equals to derivative of x squared, which is 2x, and then times 7. So that now gives you 14x. Isn't that true? Bring down the 2. 2 times 7 is 14, and then x to the power of 2 minus 1. So it's the same thing. The 7 is being multiplied at the end. Your main issue was finding the derivative of what x squared is, and that's the key. So same thing in comparison. E to the power of u, you know the derivative is e to the power of u. So even if I said 7e to the power of u, it's the same thing. It's just saying dy du, the derivative of eu we know, it's e to the power of u times 7. So that's why it's 7eu, which is why I got this. Okay? So, I mean, dy du, that's why I know it's just 7eu. Multiply those two together, so you got negative 3 times 7. So dy dx equals to dy du, which is 7eu, times negative 3. So that's negative 21eu. But u, we already know, u was equal to negative 3x, so it's negative 21e to the power of negative 3x, which is exactly the same as what I got here. You see, but this is the longer method. And all I'm doing was I found the derivative of the inside function and then derivative of the outside function. And if you've learned composite functions, this would make much more sense now. Okay, when I say inside and outside. And so you pick up ways to do it quicker. Alright, so you should be able to do question 1 now. If you, oh, actually D looks hard. I reckon D would have got many of you. So as soon as I see this, okay, I immediately think, well, remember I said if you get a fraction, you want to simplify the problem. Break it down. I know we all hate fractions. I know we do. e to x minus e to the power of x plus 1, right? All over e to the power of x. Break it apart. That's all I've ever said. Break it apart. Break it into its simple parts. So this is just e to the power of 2x over e over x minus e over x over e to the power of x. And then plus 1 over e to the power of x. So I'm splitting it all up. Same denominator. I've just split it all up. Why? Because you can simplify. This is just the same base. Indices. Same base. So if you want to figure out the powers when you're dividing it, just minus the powers. It's like saying 3 squared divided by 3. Or 21, 3 to the power of 21 divided by 3 to the power of 3. That's the same thing as saying 3 to the power of 21 minus 3. So it's no different if I wrote e to the power of 2x over e to the power of x. It's the same thing. It's e to the power of 2x minus x. See, if you can do numbers, this is back in year 7 and 8, then you can do letters. It's the same thing. Okay? So by saying that, this is just e to the power of 2x minus x, which is e to the power of x. 2x minus x is 1x. And this, we know, e to the power of x divided by e to the power of x is just 1. So minus 1. And this, you can rewrite this as e to the power of negative x, because that is a positive power. You can bring it up and change it to negatives. Now, if I asked you to find the derivative of that, so much easier now. You see what I mean? It's we know the derivative of minus 1 is 0. Derivative of e to the power of x is the same. So, and then over here, find, this is a chain rule problem. Derivative of the inside is negative 1. Derivative of the outside is still itself. Okay? So it actually becomes minus e to the power of negative x. Okay? So that means, therefore, dy dx equals to e to the power of x minus e to the power of negative x. Or you can write it as e to the power of x minus 1 on e to the power of x. Okay? So you see how I took a problem, I took a fraction that you might have been intimidated, and I've just simply broke it apart. Just break it apart. Every time you get fractions, break it apart. It makes it easier. And I know for some of you, fractions might be hard and you can't break it apart. You gotta learn it. You gotta learn it. It's so crucial. It's every year the examiners always mention how students in Victoria just are terrible at fractions. You gotta learn it. You can't avoid it. Okay? So you gotta learn it. You gotta practice it. Gotta do more of these. Right? So here we go. I'm gonna erase all this, and now let's have a look at one of these problems here with an x squared, so you can see how I'm doing them. Let's do D. Whoops. Let's do D. Okay. D. So let's say y equals to e to the power of x squared minus 2x plus 3, right? And oh, that's minus x on the outside as well. Okay. We want to find the derivative. Now, finding the derivative, see what's the issue? The issue is, again, I said it's this inside function. It's a quadratic within, it's a composite function. It's a quadratic within an exponential. So what we're going to do to make our lives easier is we're going to say, let's call this u. Why? Because this changes the problem to dy equals to e to the power of u, and this is minus x. Okay? But the thing is, you don't have to worry about the minus x because you can derive them individually. You can derive the minus x by itself and then derive this one and then put them together afterwards. So I know the derivative of negative x is already negative 1. So you know what? Just ignore that. Let's work on this side. Let's work out what the derivative of e to the power of x squared minus 2x plus 3 is. Okay? So I've changed it to y equals e to the power of u. And u was equal to x squared minus 2x plus 3. I'm using chain rule. Yeah? dy du. We know the rule. I already said derivative of e to the power of x is e to the power of x. So, this is e to the power of u. Over here, du dx is equal to 2x minus 2 and derivative constant 0. So, putting them together, dy dx must equal to multiplying these two together, so it's e to the power of u times 2x minus 2. Okay? And we can't leave it as u, so we're going to rewrite it as e to the power of x squared minus 2x plus 3 multiplied to 2x minus 2. But don't forget, you had to also include the derivative of minus x, which was minus 1. And voila, you're done. Okay, that's dy dx of the problem. Easy. Okay, so all of these questions you should be able to do now is just chain rule and the one rule that you had to use, which is that chain rule, and this together gives you question 1 and 2 of 9G. Okay. Now, question 6, same thing. That's a chain rule, and I thought I'd do one problem, but I'm thinking I'm running out of time. Yeah, let's do it. All right, let's do this one. So, same thing. It's e to the power of 2x minus 1 to the power of 4. It's a composite function again. Okay, so I said it's the bread and butter, right? So it's a composite function. It's got an exponential within a quartic function. So what I'm going to do is I'm going to say let this equal to u. Why? Why do I do that? Because it now changes the equation to y equals u to the power of 4, and that's so much easier. dy du equals to 4u cubed. Whereas I said let u equal to e to the power of 2x minus 1. Now we know the derivative of -1 is 0. We just need to find the derivative of e to the power of 2x. And hopefully by this stage you're starting to pick up the pattern, and you know that the derivative of e to the power of 2x, find the derivative of the inside. So derivative of 2x, which is 2, times derivative of the outside. When I say the outside, pretend the 2x wasn't even there. Okay, so it becomes, oh my god, seriously, e to the power of u. So pretend the 2x wasn't there and you replaced it with u already. Derivative of e to the power of u is just e to the power of u, which is itself. So that's why this becomes e to the power of 2x, because 2x is u. Okay? And so therefore u equals 2, and we know this is 0, so it's minus 0. So that together is just u du dx, sorry, du dx. Du dx is equal to 2e 2x. Put them together. dy dx equals to dy du, which we know is 4u cubed, multiplied to 2e to the power of 2x. That gives you 8. U, which we already know was e to the power of 2x minus 1, times, so 4 times 2 is 8, u cubed, which is e to the power of 2x minus 1 cubed, e to the power of 2x. Voila, you're done. Okay, so you can see how chain rule is the bread and butter. You don't know how to do it, it just digs in. Okay, you gotta know how to do the chain rule. I'm really running out of time. I'm going to jump to log, and I'm going to give you one rule. I'm going to give you one rule, and then do one problem. I got to run. Okay, so here we go. What the hell? Why is that there? What is going on? Why can't I erase? Okay. So, here we go. Find the derivative of each of the following with respect to x. Now, the only one rule you needed to know for log was, if you remember, it was dy dx. Derivative of log ex is 1 on x. That's the rule. And that's all you know. Remember, just like the exponential, I said that's all you know. You don't know log e of negative x. You don't know log e of 2x. All you know is log e of x. Derivative of that is 1 on x. Okay? So, same thing with this one. Derivative of log e of x is 1 on x. And the 2, so you times it together. So dy dx must equal to 2 times 1 on x, which equals to 2 on x. Okay? If you want to do, let's say, this problem. Okay? Same thing. Chain rule, chain rule, chain rule, chain rule, chain rule. Yeah? Same thing again. So y equals to log e of, and inside the function is a linear, 3x minus 1. Right? So, we only know if that's 3x minus 1, we're going to replace that. We're going to use chain rule. We're going to replace that with a u. We're going to call that u equals to 3x minus 1. So derive the inside, du dx, derive the inside, it's equal to 3. Derive the outside, which ignore, pretend this didn't exist, and pretend that was an x or u, whatever. then log e of whatever that is, derivative of that is 1 over u. Okay, let's call that u, okay? Because that was u. You're replacing the u, yeah? Then putting them together times these two together, that means dy dx must equal to 3 on u. But u was actually just 3x minus 1, so it's 3 over 3x minus 1. Okay, and then you can do the same for these ones. So that's all chain rule, chain rule, chain rule, chain rule using this one rule. So if that still doesn't make sense, go back to exponential, practice exponential, then come back to log. It's exactly the same. And if you understand log, you understand exponential, you can do sine, cos, and tan. You just need to know the rules. Okay, I really gotta go. Sorry, but I think I gave you guys 3 videos, an hour's worth of listening. It should be good enough for your 3 days, Wednesday, Thursday, Friday. Please practice. I'm gonna be on to you, okay? I'm gonna be literally gonna be doing a quiz, and those who don't do it, I already know who hasn't been doing it. I'm gonna get on to you guys, okay? You can't let me down. You can't let me down this year. I'm really trying really hard for you guys. Please work hard. We gotta ace this, okay? Gotta ace this methods. All right, take care, guys. I gotta go.